All right. Yeah. Let's actually get everyone back, and then all these keynote speakers and our invited speakers, I would like to hope and welcome you to the stage and take a seat. So let's get the party started.
Who's going to join me?
All right, second calling for all the speakers and the keynote speakers. Please find your way to the stage. Nice. Post 20 minutes. But it's nice that we have a mixture. Yeah, I mean it's not always same people. Yeah.
No, actually I sorted them. I can also read them from here, and you can, as I go through them, you can scroll down.
All right. At the beginning, I was making a bet to see how does the people actually find their seats. Whether the people actually just sit with your old friends or your. But at least we have actually a nice mixture. So that's better than I bet. So.
Okay, great. So let's start. Wow, 17 questions for the first panel, or actually 19. So it'll be great if you could address all of them, but for the sake of time, I don't think we'll be able to do that. But I sorted the questions, and you can see them there. The most favorite question of everybody, and would be, what's your opinion? So like all of you, what's your opinion on cloud technologies for OT systems, like EMS, SCADA? Is it a threat or a bless? So who would like, perhaps, I think it was addressed maybe to Saurabh or to Siemens. Do you think EMS SCADA systems can be deployed in the cloud? And would that be a threat or a bless? Or a blessing?
Actually, concerning this question, I have Siemens guys cheering for this question. I actually had this question asked from a customer, and there are some customers in Scandinavia that are focusing on hosting SCADA systems in the cloud already. Is it a threat? I would say no, because you can always control the direction of data that is going. So if it's bidirectional, you can make it unidirectional if it has to be. The challenging part would be how to connect your substations to the SCADA system and managing data control in that sense, yeah? And I would say that's where the security aspects have to be considered, but I would not consider it as a big threat.
And how about, let's be also a bit more pushy, how about protection in the cloud? We are experimenting with virtual protection automation control, so replacing the physical boxes with VPAC. Then maybe a little data center in the substation, but protection in the cloud?
I was actually in a meeting with a customer in Germany, and I presented virtualization to them, and they said this is an intermediate solution, and I was a bit surprised why they said that, yeah. And I asked them, okay, what do you mean by intermediate solution? And in German, they said they want Schutz in the cloud, so Schutz means protection in German. And I was really surprised with that statement. And I asked them, is this the direction you want to go short term or is it long term? And it was a clear statement, it's a long term topic. Yeah. So can protection be hosted in the cloud? The answer is yes. There are challenges that have to be, I would say, clarified in that whole story. So latency is a big topic that we need to figure out. The real-time response with protection is another topic, and the availability for protection is another topic. If you're hosting it in the cloud, you need to make sure you're hosting it on many data centers so you have real-time availability at all times. So that's what I would say.
Okay, very interesting dimension from from academia and industry. Who we innovate, yeah, why not? Let's try it, but let's hear it from the skeptics. So, who is from grid operators?
Yeah, especially the protection in the cloud. I think protection in the cloud, from our perspective, a no-go. We don't want to be dependent on any type of communication. Well, the safety functions of our decentralized assets. So maybe that's the skeptic part of it. From the SCADA systems in the cloud, it can be a backup for a potential, like if you have multiple data centers already in place at your own data centers. If you want a backup system to spin it up quickly, more disaster recovery, that you then can use the cloud as a measure for that.
But maybe, and I'd like to invite the other grid operators here. So performance and scalability and reliability is one, but we also have cybersecurity dimension of the cloud solution. So maybe Tenet would like to comment, Jeroen?
Yeah, so functionally, putting stuff in the cloud is very interesting, especially the compute part. If you have lots of data sets with lots of data from your machines, for example, for asset management, predictive maintenance, it could be interesting to move those compute loads to the cloud. However, with the hybrid warfare coming up and all the threats that are facing us, and the responsibility we have for this country and for Germany, from a security perspective and continuity perspective, I wouldn't recommend putting anything that actually controls the infrastructure in the cloud. That would be my perspective.
All right, thank you. And maybe Stedin would like to say anything?
Yeah, actually, similar thoughts. I think, from computing perspective, it's very interesting, of course, to have the things on the cloud. But at the same time, from today's point of view, I think it's, a little bit a no-go area for us as well. But at the same time, why not in the future? I think we still need to explore these options because we need more computing resources, and this is one of the possibilities. So let's see what future brings.
All right, so how far in the future, maybe? Yes.
So I've been in distributed systems for over 30 years, and I really like distributed systems, and I've always been teaching everyone that the best distributed system is the one with a central component, for a very simple reason. It's great for management, and if something goes wrong, you know where. Now, if you do it too centralized, well, you're not doing it the right way, okay? So the most centralized solutions have backups everywhere and God knows what. This is where the virtualization also comes from. Because if something goes wrong, you instantly switch over to another centralized component. So I just want to bring this into mind. I understand the concerns, and it's not just about computing, but you can put control also in a completely centralized way. Works like hell. Just my comment.
Thank you. And how about from ENCS perspective?
Yeah, a few remarks to this. One is, and it was basically what Jeroen also said, it also depends where the cloud is. And there you have a dependability. And there's another dependability, which is that if things are in the cloud and you have to rely on them to operate the grid, and the cloud is down, you can't afford that. So this is clearly not what you want to do. More generically, I would say I prefer a very secure cloud over a non-secure field system.
Would you like to comment on?
The first thought was to trip or not to trip, but you already addressed it instead of to patch or not to patch. Maybe it depends on the weather. Does it rain or not? But technically, we put it in the cloud already. In industry, it's coming more and more. Maybe a step too far. The substation in the cloud. But maybe we have to go back to Nikola Tesla and find out how did it wirelessly. But maybe that is a good research topic.
Okay, thanks. Any other thoughts on this topic? Not sure who asked the question, if he or she would be happy with the answers. Would you like to comment anything?
Maybe one question. I wasn't the one who asked the question, and it was triggered by a conversation I recently had with one of the TSOs in Europe. Because basically we were talking about resilience, And well, unfortunately, we see in Ukraine what happens if you attack the power system and what it does to your country. And he triggered me by remark saying, well, as a TSO, I can be concerned of a rogue nation attacking my substations in an orchestrated way and attacking a handful of substations, creating a power outage. But he actually only needs to attack 2 of my data centers and then everything is down as well. And that was the trigger for me to ask, okay, indeed, we are inclined to stick to the, keeping it under our own controls in a physical data center that we manage ourselves. But indeed, how vulnerable are these data centers actually?
Thank you. Anybody wants to comment on that? Yeah?
Just one thing. What lots of us always do is we mix the logical centralization with the physical decentralization, actually. So just as an example, the DNS system has a single root node, which is the dot. You know, we always forget to put the dot after our URL, but that's the dot. That's a logically centralized solution, which is distributed across, 13 root nodes. Each of these root nodes is a full-blown cloud system. And also very important, it's distributed across 14 different organizations. So the problem will shift from being logically centralized to actually having a very robust solution, not just in a technical sense, but also in an organizational sense. And this is still a great example where you see the difference between logically centralized and physically decentralized or distributed. So so I'm not necessarily in favor of putting everything centralized, but this is the thinking that we need to do a bit more, because if you have 2 data centers physically that control your entire grid system, you may not have a well-designed system. That would be my only comment.
Great. Thank you very much for all the answers and comments. Let's move on to the second question, most voted. So somebody in our panel mentioned threat detection as an application to run virtualized. Is it robust to do threat detection on the same device you want to protect? Wouldn't threat detection the first functionality an attacker would like to compromise? So I'm not sure who mentioned threat detection being virtualized, but anyone wants to comment on this? Or maybe it was related to your virtualized and cybersecurity.
I mean, the topic about threat attacks, if I understood correctly.
So we have an application for threat detection that is virtualized, running on the same virtualized environments, and the attackers would disable that first.
So the point is, you should always have a threat detection passively in your infrastructure as well. So you should have a NIDS, which is intrusion detection system, that should be passively monitoring all the traffic within a substation as well. Yeah. So you can have something deployed within the substation server, which is focusing on virtualization, but those threat detection is only for the applications that are running on the server itself. But it does not monitor the entire network of your substation. So you definitely need something external to monitor your network. Yeah. Hope that answers the question.
Okay, yeah. Jeroen?
The fact that virtualization comes into play isn't the factor here. Because if you look at systems as we know them, you have endpoint protection, like antivirus software can be disabled. You have system logging, can be disabled. Then you go to the next shield. So you have maybe network logging, IDS, IPS. If there's lateral movement, it can be detected, can be disabled as well. So that's why you do defense in depth. So no single security measure, the failing of one measure cannot lead to the failing of a complete security system as a whole. And that the same applies to virtualized detection as well.
Okay, great. Any other thoughts, comments? Yeah.
It's just, I think behind the question is also the question, can you rely on the threat detection systems? And This is, I think, when it comes to OT and technology that is available, the answer is clearly no, you can't still rely on it.
All right, then I think in the 2 minutes that we have left, we have a question to Siemens. So this, I suppose, the VPAC has been installed anywhere yet, or is just the concept phase? If yes, where and what are the results?
So I had partnered with roughly 12 customers around the world, roughly 2.5 years ago. So we have roughly around 12 pilots running globally right now. This is just I would say most of them are in a lab setup environment, but 2 of them are in a live substation. So we already have things running, but Siemens doesn't have a commercial product yet, but that's something we are working towards.
Yeah, and we'll soon have it also on the digital substation at TU Delft. And is this part of your 12 or is the extra next one? An extra, okay, great. So we will share the results with Saurabh presenting, I hope soon, early next year or so. Great, I think these are the most 3 voted questions, so thank you very much. Aaron?
Okay, great. Yeah. And I think it's also good for audience in the room. I think if you have any questions, maybe let me just wait for 5 seconds, raise your hands. Otherwise, we will also somehow, nicely connecting from the virtualization topic, which is a computer science kind of subject. Yeah, I'm surprised actually it got a lot of attention from the cybersecurity smart grid community. But yeah, that's actually a good sign. So then we will also jump a bit into the other side. And I think those questions are actually open for everybody. I would say that the top one, I'm going to read very quickly, but also in a condensed way. So because nowadays, this is about saving energy by moving computations. That's one thing many probably heard today, that, when something is not working, you move stuff to the other places. But then the question here is that people are wondering, do we actually lose efficiency in this regard? And then there are several assumptions made there. And I would like to actually raise this concern to people, maybe for the computer engineer community, you can respond to that. And also maybe for the power grid community, you can also think about from your perspective, do you think it even makes sense to move your computation, move your management, OT, IT, hopping around? So that's the first question. So I'm throwing this to everybody on the floor. Who want to take the first shot?
Question, right? Okay, yeah. So indeed, one of the things, the difference between the edge and cloud, or the big data centers, well, one has more compute power than the other. But now looking at, for instance, mobile phones, they are really quite powerful. So you can run quite many applications on those devices. Only maybe they are not optimized, for instance, for power efficiency. So data centers have, huge investments and also regulations to make their power usage efficiency lower the better. But the edge devices are not maybe optimized for that. So that's also one of the questions I have in mind. But losing accuracy, I think, it really depends on what kind of applications we are talking about. So is there a big difference between 99.99 accuracy versus 99.90 accuracy in detecting an object? So maybe the loss in accuracy is not that actually something bad, because in the end you would only notice it out of I don't know how many tries, etc. So I think indeed there's a fair question here. So we need to understand the trade-off. What are we losing and what is the benefit? I see Andy has a comment, maybe. Shall we?
I think this is a really relevant question. And to be honest, I do not know the answer here. So as of a few days, I have Apple Intelligent on this device. And what I do notice is that the uses of my AI got increased by a lot. Yeah. So that brings me down to Jefferson's paradox again. So I'm using these services more and more because it's more available to me. So I'm not sure indeed if Edge AI will, let's say, lead to lower energy consumptions in my view. It's not clear to me.
And I would say that there is also an interesting embedded one is that, many people make assumptions in this regard. And then typically, I think maybe one thing I want to also ask the power engineers, we have been debating that people think clouds is the edge, they are the competitors. And then I guess nowadays we have a better understanding in the computer science community. But I don't know, now today you hear a lot about the edge. What is your impression? Do you think this cloud is actually, after you hear about the edge, do you think they are actually our competitors or more like, killer for each other? And maybe what's your impression? Yeah.
Is it on? Yes, it is on. No, it goes hand in hand. I don't think there's competition in distributed control systems. That's where I originally started in substation automation. And you want to put the functionality as close as you want, as possible, close as possible to where you have to perform it, because there's all your data. That's your realest time function. But then you still have to talk to others, and that you can do in the cloud. So it is the interaction, and it is the combination together there, the distributed control. And yeah, the good thing of the cloud is that you can replicate it quickly. And the edge, if you lose one part of edge, then how much impact does that have? If we look at the whole energy system, we want to keep it available, keep it running, and for as many people as possible, and also do it efficiently. But so for me, it's not a competition; they go hand in hand. Anybody likes to comment?
Well, I think it's kind of a very old discussion, the mainframes and the personal computers. In telecoms, we have seen the trend that things move more to the devices. If I think of my first university lessons in computing, I was not a teacher because they were really scarce back then, but you had the big mainframes. And if you think of the computing power of the big mainframes and the power consumption, and now you see what an iPhone can do and the power it needs. I think, this is kind of the parallel that we might be seeing in the grid domain as well. And what it means, digitizing the grid, it means you produce more data to make meaningful use cases out of it. You have to establish what is it that you need and what do you not need. But in general, there will be a higher demand for computing capacity. So this is a tendency that I can see. The most efficient way how to deal with it, I can imagine that there is an opportunity in the edge computing. I can imagine, but it's very hard to predict. Yeah.
I think in the energy, I'll only talk in the energy landscape since this is my domain. I think the use case is very much defined for cloud versus the edge. So edge is to make your existing local setup, or in this case, the substation or a site, more intelligent. Yeah. Whereas edge cannot scale. So if you want to see the visibility across your fleet of substations, that's where the cloud topic comes into play. Yeah. So you will need to connect your edge to cloud so you can see a bigger visibility of your fleet. Yeah. And that's the clear use case, at least what I see in the industry, where cloud shines when the edge doesn't shine. Yeah. And in that whole equation, and this is something that I struggle with today, and most of people I talk to, they also struggle. What is an edge? Is edge something that connects to the internet, or edge is a sensor that is out in the field that is sending information? So that definition of an edge for me is typically not clear, frankly speaking. Yeah, but for me the use cases are clearly defined.
Eric? Yeah, maybe from the telecom domain. I don't think, at least today, but I also don't see it, that electricity consumption would be the driving factor to move workloads to the edge or not. Even some years ago, we thought maybe latency was really important for the edge. And of course it is, but we see many other reasons also to use the edge. For example, some companies want to keep their data on premise. So they want even some mobile network functions, we can deploy them on the edge, owned and on the premises of a company. So there are many different reasons, I think, where you would like to do things on the edge or centralized. And yeah, for us also, the dependability is important. So, for example, we have some criteria for outages. For example, the internet access, the computers that we use for that. We could then centralize that on those 4 locations in the Netherlands that I showed. But then, in the case of an outage, you would lose a lot of customers. So we decentralize that. So I think also Edge you can use to distribute and become more resilient. So I think there are many reasons to do things on the edge and trade-offs to be made.
And just to quickly add, I think there was a question about Ukraine. If you attack 2 centers and you will lose visibility of your substations or site. And this is a prime example that you need to connect your edge system to a cloud. So if the cloud goes down, you still have workload packages running on the edge. It might not be the full-blown version, but there has to be some dependency there.
Okay, thanks a lot. I think this is actually very interesting crossover kind of reflections from both sides. And then, yeah, go ahead.
In addition, as a grid operator, we are also running an edge computing project. It's very much a pilot and it's very basic at this moment. But the architecture that we are considering is also more in the direction of a hybrid or more distributed kind of computing. Which can also combine the cloud and decentralized units with each other, with the advantages as mentioned by Siemens. And one of the things is also, if it is fully centralized, it might not be feasible anymore because there's so much data exchange that the communication network can also get congested and it may not work efficiently as desired. I think that's also one of the considerations in the planning of edge computing. Thank you.
Yeah, go ahead. Maybe to complement what you said, because we are working with Stedin on that project, and we had a study that what are the main advantages of using edge computing for grid operators, especially DSOs. Because Stedin is investing a lot in edge computing and they want to explore that, whether there's future in that. And based on that study, most of the high potentials of edge computing is related to data, because we don't want to, especially for dynamic congestion management, efficiency, it's an issue, but energy efficiency is not such a big issue, and we want to have data, local data usage as much as possible, and sharing data centrally is really not possible. And there are also some restriction on, especially at industry level, at what data they want to share. So they see this as a great potential that edge computing can bring into dynamic congestion management, especially for DSOs.
I would like to add one point from the AI perspective about Edge AI. So one beautiful application of Edge AI, I think, is predictive maintenance, where you have an AI module running on an MCU microprocessor, monitoring the condition, for instance, of a high power transistor in an electric drive. That model may continue to learn, so it's learned locally, but it may be derived from a base model in the cloud. So every now and then, maybe this local model gets retrained or gets updated from the cloud every now and then, but it doesn't have to maintain continuous connection with the cloud. So I think it's a very natural way of balancing the cloud AI and the local AI at the edge. So predictive maintenance is one application.
Yeah, there's one other thought that came to mind, basically, is that, which is very relevant in the context, is that we are moving away from a central generation grid system into a distributed one. And the distributed ones and the grids, the city grids and even smaller, from the perspective, how can it be self-sustainable? So you can be off-grid almost. Is becoming more and more in tendency as well. And this is kind of where you can by definition, use the concept of edge computing, and in relation to the energy provision, because if you have a self-sustainable grid, you can, make use of that.
One more point. It's about power systems, not my area, but I will try nevertheless. I think renewable sources is another domain, because you would like to perhaps forecast the sunshine in the local area. So you have locally running some deep learning models that you don't want to centralize. It's because these models are running locally. That's maybe a good application. So you model the environment, whether it's weather or load profiles, etc. Mm-hmm.
So I'm getting increasingly confused here. When people talk about a cloud, do they really mean something like a big data warehouse where I don't know where it is? Okay? Because I just heard one very good argument. I don't think it's about clouds versus edges. So Eric, you mentioned resilience, okay? So this is where the physical component comes into play, because coming back to Ukraine, if you, and I'm not a Power Web expert at all, but if you have everything in that sense centralized, so basically it's not resilient at all, then probably by design you did something wrong. You actually triggered something if you have 4 control stations, and call them data warehouses where you control the entire grid. That is not a good design because it is not resilient enough. But it's not about cloud versus edge. You want to have smaller units that can act independently from each other, because that's much more robust. I don't think that has anything to do with edge versus cloud, because you can build a virtual cloud and distribute it completely physically, such that you have your resilient units. So I don't think we should mix these two. That's the reason why I'm getting confused here, but I think I'm going to get some comments here.
So I think, resilience or autonomous operations, etc. So units can operate autonomously, but at the same time, what is kind of the backup for them? So resilience also comes from the fact that, they can operate autonomously, but they can also be connected to the grid and make use of the grid, or the other way around. So the islanding options, etc., are of interest. And therefore, it still comes not everything autonomous as such, but also how they interact, I think, with the bigger picture and the edge environment. So any...
Right. So I was a bit confused about edge computing, but this conversation got me thinking. Basically, we have been doing this as grid operators from the very, very start, because mechanical relays are basically big state machines, which are edge computers that control the big devices outside. So these are autonomous. The IEDs, intelligent electronic devices, which are basically computers. Not basically, they are computers. They work autonomously, but they also work together, and they work with central systems. So we do have cloud and we do have edge computing, well, from the early 60s on to now. At Tenet, we are deploying extra edge computing then, but as few as possible, because we like to keep systems as simple as possible. So we only do that for big data sets, like, for example, dynamic acoustic sensing, where we check the undersea cables. Those are really, really, really big data sets that cannot be easily transferred. So to get near real-time results from the data, we need to do edge computing and send it to a central location for further processing. But that's our use case for this.
Yes, maybe building on the comment of Maarten, I think in telecoms we have a cloud native architecture. And so basically for us, cloud enables us to be more resilient. For example, in the mobile network, we have what we called in the past big customer database, HLR. and we only had one of that, and we replicated it in some other place, so we had a backup. But now, instead of a physical thing, a big computer, it's now a software component. So we can even have that database specific for one company, for example, for security reasons. And also the core network, that's a big computer in the past, and now it's a software function that we can also decentralize. So cloud-based basically enables us to become more resilient. It gives us the flexibility to do that.
I just want to make a small comment. I think what you described is what I was alluding to. I think the definition of what's an edge is very confusing. Because what you described is protection, electromechanical relay sending data to a gateway system and the gateway connecting to a cloud maybe. So what is an edge? Is the edge protection device or is the edge gateway? So it's the definition of what an edge is. At least it's blurry, and I think that's what causes a bit of confusion. Yeah.
You don't have to ask any questions anymore. We're just now autonomously.
I guess that's the fun panel that we want to see panelists, the debates, argue with each other, because otherwise it's too much.
The discussion coming back to what is the edge, that is how you define it. It can be in the substation on the feeder, but it can be your house, your smart meter, and everything we put in there in between. So that is edge. It was already working in the past in that way, only we did not do it electronically. But we had a brain sitting on a feeder having to autonomously trip, and on a mechanical way. And then now we put controllers in that we can talk to and work. But it's coming back to the earlier discussion. This is control engineering. How do you spread your risk? Control engineering and risk management. And then what is the wisest way? But we evolve in, and this is what I mentioned with the accidental architecture. I wanted to say stumble upon something, but we take a decision now or do this, given by the technology that is there at that time. Our industry runs a long time with this technology. That's why we have all these different generations, and now these new things come. And now I understand we have the cloud at the edge, but So we have a lot of small clouds, but it is really about doing the control system engineering with the risk or minimizing the risk and being able to make it resilient as possible. Energy efficient is important, but today energy independence has become more important, and now we're willing to pay more for it. So it changes over time. And we have to keep up with it. So it's actually very good that we have all these different disciplines talking together now. And maybe we can continue.
Yeah, and I think for the last 5 to 10 minutes, we want to give opportunities. So we are not forgetting you guys in the room. So, and I think in respects for those all the lovely and kind of active panelists, maybe please raise your questions directly from here. Anyone who have questions already in the screen or send it has not been asked yet, but you really want to ask now, please raise your hand and we can give you the mic. Anyone? Yeah? Go ahead.
Yes. So the question about the second part, the first question, was actually my question, and I think not all of it has been answered, because the question that I had initially was, why would edge computing be more energy efficient than cloud computing? Because I always heard these scale advantages of scalability, the hardware optimizations. And then moving that to the edge, that, in my opinion, then you do not have those scalability efficiencies and so on. So can you explain to me why is it more energy efficient when you're doing the computing somewhere else?
One of the things Yeah, one of the things is like we don't really know much about the cost of transmitting the data, right? So the data needs to be transmitted. So it comes with a cost. So is it big? We don't know actually, because there are, to be honest, in the models you would see, in the academic literature you would see it's based on traffic volume, but it really depends on the routers, etc. So one additional cost is the communication cost. And also it comes with all these, you need to secure the data because you need to transfer it. Maybe you need to implement some kind of cryptographic protocols because transmission needs to have all these things. So one reason could be the overhead to communicate and secure the data because you need to transfer it. It really depends on the communication part, for instance. But there is no clear answer why one would be more energy efficient. I don't like efficiency, to be honest, but yeah, footprint is more important, I guess. That's why we usually say, well, one or the other, it's not the case. It is the continuum. So depending on the later, and energy efficiency is indeed not the only requirement or the reason to go for edge. As Eric mentioned, resiliency, data privacy, I think those are maybe also quite important, right? I'm not sure if your question is answered, but communication is
partly,
one part of the thing.
yeah. But so you don't know what that is actually the answer because you need the transmission energy.
Yeah, so I think the transmission in the core is not consuming that much energy. So that would not be a reason to push things to the edge. But for example, one of the first things that we did to decentralize was what we call content distribution network. So for example, if you look at Netflix, and if in the Netherlands a lot of people multicast or watch a Netflix stream at the same time, it's more efficient to have that content close to the customer, because then you just have to copy the content once. Netflix does that, for example. And then from that place you have basically the stream. And otherwise we would have kind of millions of streams, same streams through the core network. So basically it's not that the core consumes so much energy per bit, but it's more like in that way you can prevent a lot of transmissions from happening. So there's that type of optimization going on. On the other hand, so this we could do. On the other hand, for edge, so if you would think of, okay, we have the edge and we do cloud, like we do all kinds of cloud services that are available now, there are certain regulations for the edge location. So if there's really user data basically unencrypted, so from our network to some third-party application, so there's potential vulnerability, so then that edge location needs to meet certain criteria. So therefore, maybe an edge on each of our base station sites would be impractical, because then you would have to have physical protection of those sites, so that cannot be tampered. So there are lots of things, lots of criteria to see, what the right edges are for which application.
Another point is, I think, the compute hardware. I think at the edge, typically you don't have a GPU, you have maybe a microcontroller, FPGA, so you're forced to compress the model to fit in that small computer. Whereas if you had access to the cloud, you can just run a big model and you wouldn't care. So I think running something at the edge forces you to think and make a model more compact. So that in that way you can save energy.
And maybe looking at the overall picture, energy efficiency, first of all, is not the only factor. Like there are other factors to consider in design. Like there are some limitations that which of the two is the better solution. And if you consider all of the consideration, edge computing, even though that it might be that you're less energy efficient, still you would go for that.
Okay, thanks.
So can I, one more comment. So you see, there's a lot of speculation here. So no one knows your answer. Yeah, so I think that is your answer. I mean, it's unclear until there's a real study being done that really shows what is better in what context, I would say. So I think it's wrong to use energy efficiency as the driver for edge computing. I think there are more, it has been discussed already. So privacy is one, latency is another one, personalization is another one. Yeah, so you move the intelligence closer to the user so that you can personalize it, which is much harder to do in the cloud and so on. So I think for now, I think it's a wrong motivation to do edge computing just for energy efficiency. But that's my take.
Okay, thank you. I think we have time for one last question. I think Peter was first.
Yeah, it's not a question, it's just a comment. If I put all these things together, the energy efficiency of a certain location of a computation and also the other requirements of latencies and availability and maybe privacy security. If I put that together, I end up in a full-fledged network operating system where everything's software defined. So protection relay is maybe a function. It's a piece of software, mobile, huh? It's like a mobile agent, a cloudlet, it can move around. And it would learn by itself, it should be closer to the process because it needs 3 data points within 2, 3, 4 milliseconds, and it doesn't get it in the cloud. Yeah? And maybe backup protection would move into the cloud because it's cheaper and it's safer and more availability than down there. So I think that could be, of course, it's long-term, self-organization, self-evolving zoo of functions in the end. But if we think that through as a very future cyber-physical system, where the platform tells me if you're here, you get this price for running and these latencies for these and these data points, then it would organize itself. And now we do everything manually. We decide, we put this here, we put that there. It's all crafted by people. And maybe it's getting more and more complicated that we should allow the system to configure itself. Of course, trusting that it converges and works in the end, that's another question.
You can always disagree with him. So, yeah, Mike.
I kind of agree, but I think if you have such a system that's fully self-configurable, it has to be able to explain itself, like why has it chosen a particular configuration. So if you were to apply like deep neural nets, maybe that wouldn't be the great thing because it would give you configuration, this works well, but as an operator you would have to know why, and what if it fails, what do we do then, what's the backup plan? So I think yes, but the system should be able to tell you, I've chosen this because of the load there, and then certain weather patterns and customers want this and that, so then that's why I've chosen this, but I have also option B and I have option C, and then what do you think about that? So maybe it should be like an interactive system that helps you to configure the grid, so it should be an interactive system.
Well, Martin, be brief, yeah, given the time.
I can be very brief. I really love your remark from a distributed systems perspective. You just brought everything into the virtual domain. Thank you for that.
We have actually one burning question. I see either Simon or Harald, but maybe Harald, if you want to shout, last chance. 1, 2, 3. So.
As you may or may not be aware, that as of the 1st of January we have the new energy law in place in the Netherlands. And part of that is Article 4, dealing with data exchange. And my question to you is, the mandated access to metering data, energy system data, I don't have to shout anymore, the mandated access to that energy system data, like metering data, is that a blessing in disguise for AI? And does it also have implication in positive or negative way for cybersecurity?
So your question is yes or no? Okay, how many of you go for yes? How many go for no? So let's do it this way. So that sounds like a yes or no question. So yeah, what do you think?
And you can explain the regulation in one sentence. Okay. There's Mike again.
No, that's not Mike.
Right now, there's no penalty for accessing metering data from consumers, so everybody can make use of it, even though the AVG is in place. As of the 1st of January, you're allowed, if you have a mandate for accessing that data, you can get that data via the gegevensuitwisselingsentiteit, or the new legal entity which comes into place as of the 1st of January. That means that the consumers and also the companies can retract that mandate as well. So they have full control over accessing that data after that date. Do you consider that to be a step forward in terms of cybersecurity, or a step backwards in terms of we have a new cybersecurity threat? I'll leave the AI part out.
Okay, so I'm from a TSO, so I don't have to deal with all the headache of smart metering. From my perspective, it would be not per se a cybersecurity leak, but a plus in the right direction for autonomy of the individuals, of the people. Yeah, and it would be a big plus for AI as well. Just to answer that question, all data is a new learning point. So, yeah. Any one of the DSOs can answer that about smart metering?
Yeah, I think, yeah, because a lot of issues, of course, with the network capacity management on the low voltage side, and it's a completely blind spot normally. You have a lot of synthetic approximations what's going on there, but when you have more and more data access, then it's becoming more and more clear the situation, and it will also help for our capacity management and efficiency of our resources, basically, grid investments. So I think that's very important, the availability of good smart metering data. So that's, but cybersecurity, I cannot comment much. My colleague is here actually with cybersecurity. Maybe he wants to comment something.
It's a tough question, but it's a nice one.
I'm thinking, I was thinking quite hard, like what would the impact be on the cybersecurity perspective if we look at our smart meters, and then specifically from a data perspective, our smart meters cannot switch at this moment, so there's no switching in there. So it's mainly then the loss of information you get from the smart meter to your central systems. Is that where you're aiming at? Yeah. So then the cybersecurity risk would be that someone would change that mandate and that we don't have the insights anymore at the moment. Yeah, okay, fair enough. Can be a potential route, yeah.
I guess, yeah,
I don't think we have probably completely answer for that today, but that's actually a good way for ending our panel, given the time and given the discussions. Let's actually give applause to our panelists and the keynote speakers.
Great. Don't leave yet. We have a networking moment, but before that, we would like to hear from our sponsors. So we have two very brief presentations. We have here Tom Van Rens from NWO, who will tell us about the upcoming funding opportunities.
Yeah, so happy to be here. What I usually do is I develop new calls for proposals for the energy transition. That requires a lot of talking with a lot of people, and also going to places like this. Yeah, of course, please make some space, please, people. And I'm not going to talk to you about the more generic funding opportunities like the Veni Vidi Vici or the open competition. I did a quick run through our database for 2024, and we received in total about 500 applications for funding last year, only for energy-related research. So it's we have quite a lot of things going on. What I will talk about is how we actually get to the new topics that the more thematic calls that we develop. And that comes usually down to, does this work? No, it doesn't. It does work here. That's not my presentation. No, it's fine. Anyway, what we usually do, we work together with the ministries, with companies, with the top sector energy, and we usually follow all the things that are happening in the world. Yeah, there we go. Yes, there we go. So we have the knowledge and innovation agendas. These are big reports of what's going to happen, what we need to happen. And we just look at that and we say, well, maybe this might be a good topic. And then that's always really broad and not detailed. And then we go and talk to researchers like you. And we talk to the Netherlands Energy Research Alliance, and we come up with different themes. One can be, for example, on digital twinning and how you can build that for the electricity sector. That's something that I will get to later. But another thing that we can do is social dynamics in energy transition. That's also something that came up. But now, of course, we have a lot of national and global trends. And one of those is the National European Raw Materials Act. Raw materials, more of a strategic autonomy point of view from Europe. We need to do something with all the materials that we have in the Netherlands. And there's a lot to be done. So it also comes down a bit to resilience. Not necessarily cyber resilience as we talked about today, but also resilience as a whole for the energy system. What happens when there's big flooding on the energy system, what happens, etc., etc., etc. There's a lot of research also to be done there, that can be done there. So that is in development. We will build that further on this year. So there's no open communication on this yet. You cannot find it on our website, but we are working on that. So furthermore, we have a system of systems analysis of energy of materials in the energy transition that's in development, and there's one on the critical raw materials in energy transition that is just barely published, I think. Nuclear, we do something with nuclear as well because that's a political topic. So we will have a call on resilience. We developed this, so what I want to say is that we developed this with industry, with the ministries, and also with you. So this is also an invite for you to come talk to us at NWO, to me or my colleagues or whatever, if you think, well, there really needs to be a push on this certain topic, and we can maybe find a way somewhere that we can find funding for that. That does not necessarily mean that you have to apply for it in an open competition or a more competitive kind of call, but we can maybe tailor a certain specific thematic call to that. One of these is the electricity sector. We want a digital twin for that, maybe. Maybe we could. At least TenneT would like that. And we thought, well, that's a nice idea. Let's do that. We will partner up with you, TenneT, and also the ministry thought, well, that's a good idea. Here's another 1.2 million. So NWO and TenneT, we have, it's open now, it's published. We have a call where we will unlock the digital twin capabilities for electricity utilities. Deadline for pre-proposals is around the 10th of February. In January there will be some information sessions. This is the first of 2 calls for proposals. There will be a second one later. And this is one of the bigger ones that are being developed right now. So I'll leave it to that. There's a lot more, of course, but just 5 minutes. I just cannot touch everything. Thank you.
Thank you very much, Tom. Now, our final presentation, very brief also, is from Siemens. We have Corne de Hoch here, so Siemens, please.
Since I'm the last guy before you can go to drinks, I will keep it as short as possible. If my presentation can be found. Yes, so I work for Siemens, the Netherlands. It's a bit singing, but fine. Smart infrastructure, electrification, automation. It's a mouthful. Don't remember it. We have a lot of different business units with a lot of names. We change them every few years, so please don't remember it. Where do we see our market? Well, our market is kind of everywhere. So it's campuses, it's data centers, it's water, it's everywhere. Our key strategy at the moment is DSOs and TSOs, where you also see it on the left side, and data centers, because that is the biggest growing market at the moment. We have over 12,500 people working worldwide for this, where we have at least 26 factories. We produce everything mainly in Europe, in Germany, for our protection, automation and control and our medium voltage. As you can see, a snapshot of our portfolio. We start at component phases, but we'll go all the way to even commercial e-houses. So if a customer wants, we can deliver everything turnkey just as a plug-and-play system for them. But we have all the manufacturing in our own hands, so it's great for us. Together with Alex, we are thinking about what do we need to do in the future. And one of our platforms is Electrification X. Electrification X is one of our, how do we say it, platforms where we build stuff. Oh, we need to go out. We have to move? There's a light sensor. Where we have asset management, but also load management, network fault detection. It's all cloud-based. It takes the data from the customer and they can manage everything in an online platform. At some point, you can see it hopefully somewhere in Alex's room. We also have a SIEM, so of course we never are free of issues or never free of troubles. So we made our own security information and event management, where we sell this to customers that have problems and want to timely detect suspicious activities and that kind of stuff. Digital twin, a lot of talk about today. We have one. We have a fully digital twin of our Cyprotec. It's based in the cloud. You can do everything. And also, it's really funny because if something is wrong in the hardware, it will also be wrong in the cloud. It's really cool. Grid Edge, also a lot of spoken about today. We have our gateway where we connect with our hardware to the cloud. End-to-end cybersecurity, so we have a full team that only assess, implement and manage for smaller companies for their cybersecurity. The big ones are doing it themselves. They have their own CISOs. But small companies have a lot of problems with their cybersecurity, though they come to us and ask us, can you help us? For that we have a full offering. We even have our own cybersecurity substation blueprint model, which is certified by TÜV. Sorry, Bas. Sorry, it's certified by TÜV. But this is our key principle on which every substation that we build for either ourselves or customer or anywhere in the world will be built upon. If you want, I can send way more information, but I only have 5 minutes. So all these things, what do we do with them? Well, A, they're for our customers, of course, but B, we are also starting to implement them at the digital substation of the future. I don't know who has done the tour and even went to the control room of the future. Next to it, there's a secret door. If you open it, you will go to the digital substation of the future. There is the RTDS, but also nowadays there are 18 real-life relays that are communicating with the RTDS, and they are now installed. We are getting them operational, and there we will start to do digital twin versus a VPAC versus what is a normal pack. So we are gonna really demonstrate what will a VPAC solution look like, how will it handle, how will it operate versus a PAC system. But also, as you can see in the banner, which is also over there, cloud solutions. So like I said, Electrification X will be installed, a SIEM will be installed, but also We will go further with one of our partners, Nozomi. We will also install IDS and everything. And that will bring us a full cybersecure and cyber resilient system, which will be tested by TU Delft, but also by ENCS and by all the other partners in the consortium. So in the end, we hope that we will have a safer substation tomorrow than today. If anybody needs to know anything, Alex is always there, I'm always there, so feel free to ask questions.
Thank you, Gordon. Now, I would like to thank all the sponsors. They have been great supporting this event, and we are very grateful to them. Yeah, Aaron?
Okay, yeah, I think we are approaching the end of the conference, and I think when I'm looking around, I would like to actually, together with Alex and we want to actually thank everyone making your time today. So I know how difficult nowadays to have, reserve a whole day coming to an event like this. So in the very first place, we want to actually deliver thanks to all of you, and then also to all our kind of the colleagues actually making this whole thing running. So because for me, it's amazing. I did not actually book the events or do whatsoever. So all the credits go to Alex, to Yumi, to Lily, and all the PowerWeb team. So in that sense, let's actually maybe give the applause to them and also to yourself.
Okay, and I would like to introduce Lily. She's leading the PowerWeb, and we have Yumi as well. Lily, would like to say anything?
Okay. Thank you. Thank you very much. Now comes to the highlight of today. We also would like to thank all the speakers. And first, we would like to invite all the speakers to the stage. And we have a small token for you. Please, speakers, come to stage. And also, please, come to here. It's nice to take a photo together. Yes. And also, no, you let them. Yeah, okay. And also, at the PowerWeb, we would like to promote diversity and inclusiveness. No. Hey, Alex. No, wait. We would like to promote diversity and inclusiveness and also change the perception that when women are in the conference, by default, they are secretaries and handling the gifts. So now with the generous help or support from my kind colleague, Aaron and Alex, now they're going, Yumi and I are going to give our keynote speakers and the panelists the gift. So thank you. Okay, Yumi? Yeah. Okay. Okay. Yeah. We still need to get used to it. You can see that. Okay.
I almost ate it.
Okay.
Yeah.
Thank you. Thank you very
Lily.
much.
Yeah.
And thank you, Aaron.
Thank you.
And also thanks to Aaron and Alex to help with the cultural change.
That's wel leuk.
Thank you.
Zo vandaag.
Yeah.
Thank you so much.
Thank you so much.
I think we have a couple of people leaving already, so that's okay.
Yeah, but we still have other people. Yes, next one. Yeah. So, of course, we would like to thank our lovely sponsors. And you made the free lunch possible. And please continue sponsor us next year. And if you increase your sponsor amount, you will get a longer time. So, thank you. Okay, next one, please. And of course, also want to thank our co-chairs, Alex, Stefano, and also Arundin. They put a lot of effort pulling together a fantastic program and also top class speakers, panelists. So thank you very much for that. So Yumi will give you also both of you a gift as well. Thank you. It's getting complicated logistically. And yeah, so So next but not least, also thank the support team. And last night at 7 o'clock, they were still printing badges. So this is just one small example of all the effort they put in. So thank you very much for that. And you are the unsung heroes. Thank you. And I would like to invite Peter and Alex to the stage, so our complete PowerWeb team. And so, if, PowerWeb, of course, we have also the steering and executive committee team, but this is the working group. And so so if you would like to collaborate with us, contact the four of us. For the hard scientific questions, contact Peter. For all the rest, contact our public affairs and communication manager, Yumi, and the program manager, Alex, and myself. Thank you. Thank you very much. And Yumi have a small announcement.
Just really quick, a plug for the Pioneering Tech, which is an Innovation and Impact Center publication hot off the press. It covers all sorts of innovations to solve big societal challenges. This issue has stuff on nuclear reactors, which is mentioned before. It has offshore wind innovations, all sorts of things. So they're over there by the registration desk. So on your way out, please feel free to grab one. There's a Dutch and English version. And then I think the tour for the Control Room of the Future probably would start right now. So maybe if we can join our wonderful guide here, as we close, he will lead you to the tour. And then the rest, enjoy the bottle.
Thank you.